Hello there! In this video, we are going to cover 7 simple tips for Python beginners. And I really want to stress this is for beginners. If you are a more seasoned programmer, these are probably very simple. But to go over them, we're going to cover these 7 examples that should help you write better code in Python, or at the very least more elegant code. And, well, I guess let's jump straight in and let's have a look at all of this. Here we have a completely empty Python file. And what I want to start with is called match case. And basically what this is a simplified if statement if we only want to check the values of one variable. For example, if I have the variable a and the value of a could be 0, 1, 2, or 3. Let's say for now I'm going to keep it at 2. And I want to write an if statement for every single possible value that a could have. Now, most beginners would write if statements. So if a is equal to 0, and let's say we want to print 0, and then I can copy this a couple of times, and we get the values for 1, the values for 2, and let me copy it one more time. We are getting the values for 3. And if I run this now, we get 2 right now because we have this if statement. I guess to make this a bit more connected, we can also use elif statements and we will get the same result. Now, this is technically fine, but also not particularly elegant because Python has something much better for it. And that is called match case. And basically what we're doing in here, we are writing match, then the variable we want to check, then a colon, and now we can add different cases. For example, case 0, and if that is the case, I want to print the same thing I've printed earlier, so 0. And then I could copy this a couple of times. So let me change this to a 1, this to a 2, and this to a 3. And with that, we have the exact same outcome. This here and this here do basically the same thing, meaning if I run the code, we get the same outcome. The difference is that this, I think, is a fair bit more readable. And I guess you could make all of this even shorter by putting all of this on one line. And this is feeling much more elegant than all of this. I guess, granted, you could also put if statements on one line, but it would still not look as elegant. So basically choose for yourself what you would prefer. But most of the time, I would go for this one because it's just much more readable. Although one really important thing about match case is that it is a fairly recent addition to Python. I think it was introduced in Python 3.10, so you might not have it. If you don't, just update your Python and you should be good to go. And all right, that is the first tip, and let's come to the second one. And this one is called a ternary operator. Or to simplify things a bit, this is a single line if statement. And how this one works. Let's say I have a datetime variable, and right now this is set to true. And depending on the value of datetime, I want to assign a value to greet. Meaning greet could either be hello if datetime is true, or it would be goodbye if datetime is false. Now, what you could be doing to assign this would be something like if datetime is true, then greet is going to be hello, and else if that is not the case, then greet is going to be goodbye. Would be fine, although this is a ton of code for something so simple. So we are not going to do that. And instead, what we can do is get our greet variable. And now I want to assign hello if datetime is true. And if that is not the case, else I want to assign goodbye. And this line here and these 4 lines do the very same thing. Meaning I can get rid of this one, print greet, and we're getting hello if this is true, and if it is false, we get goodbye. And this simple line here can be surprisingly useful. where you see it most of the time, I think, is in f strings actually. Let me create one. And let's say I want to print something basic, doesn't really matter what it is. And inside of the curly brackets here, I can also use this ternary statement, meaning I can just copy it in here. And now the only thing I have to do is to be careful with my quotation marks, because Python does not like mixing them up like this. And if I run this now, we get something basic, goodbye, because datetime is false. And this is a really nice way to add more values and more flexibility to f strings. It's really useful. And that's basically it. So with that, we can come to number 3, and that is chain comparisons. And that's probably the easiest part in this entire video. Basically, what I'm going to do, I have a min value that is 5, I have a max value that is 10, and then I have my actual value that is 7. And all I really want to check is if my value is between my minimum and my maximum value. And I guess a correct way of doing it would be something like if min value is smaller than the value and max value is greater than the value. And if that is the case, I want to print value inside boundaries. Now, this isn't wrong, and it would work, meaning if I run the code, we get value inside boundaries. But this is also really hard to read, meaning we don't really want to use it. Instead, let me copy it. What we can do, which is much better, we can just remove all of this and chain the comparison operators to something like this. And this is still working, meaning if I run the code, we get the same outcome. But this now is drastically more readable. And for some reason, lots of tutorials don't cover this sort of thing, which means lots of beginners write code like this, which is kind of weird. That is chain comparisons, super simple stuff. Next up, I want to clamp some values between a minimum and a maximum. And let me just copy the earlier values so we have some numbers to work with. And let me increase them though. Let's say my current value is 50, my minimum value is 0, and my maximum value is 100. What I want to do, let's say I am running something like a game, so I have a while true loop, and inside of this while true loop, I get my value and I add some number to it, let's say 0.01, doesn't really matter. And now I want to make sure that value never exceeds maximum value. I guess let me print the value and run this, and we very quickly get really high values, something that we don't want. And I guess one way to avoid that is if value is greater than the max value, then value should be the max value. If I run this, we stop at 100. And we could also do, if I now subtract the value, we get to negative values, meaning I could copy all of this. And now if my value gets smaller than my minimum value, then I want to set the value to the minimum value. Meaning now 0 is the lowest value and 100 is the highest value. And again, all of this is okay code and it works, but it's kind of clumsy and we can write more elegant code. And how this would work. You first get the minimum value between your actual value and your max value. That way, we can never exceed this max value, regardless how big this value becomes. And that way, we are basically covering this part here. And all of this, I want to wrap inside of the max function, and inside of that, I want to check my minimum value. Meaning now I am checking this maximum value here against this minimum value. And we are picking whichever is higher. And with that, we can comment out all of this, run the code, and now we get the same outcome. We can go negative, we can go positive, and we have clamped the value in one line of code. And I guess, let me go over it really quickly again. This can be kind of confusing. Let's say this value here is 120. And we know that max value is 100. And since we're checking minimum, we're getting rid of this 120. And as a consequence, this entire value here can never be greater than this minimum value. And on the other side, let's say if this value here is -20, the max value is still 100, meaning now the minimum value is going to be -20. But now what we are doing is we are looking at this minimum value here, which in our case is 0. Meaning what Python is doing now, it checks the maximum, which one is bigger between 0 and -20. And that way, we are never getting lower than this minimum value. This kind of line here is super useful, but it is going to take you like a minute to understand it. So do take your time with it. It can be incredibly useful. But all right, I do want to keep it simple, so we are done with this one. Next up, I want to look at eval and exec. And those are both functions that allow you to execute code from a string. Let me demonstrate actually. Let's say we have a test string that right now is something like hello. And what eval, for example, allows me to do, I can run a string with 1 plus 2. And if I print all of this, then we are getting the result of 1 plus 2. If you ever made a calculator in Python, you probably used eval already. It's kind of a useful function. And it's actually much more powerful than that, because what we can do inside of this string is even call other functions. For example, I can get my test string and then call upper. And if I run this now, I get hello, all in uppercase letters. This hello here. The one limitation eval has, let me copy it, is that we cannot assign new values. Meaning if I try to assign a new value to test string, let's say updated, I would get an error because we get invalid syntax. And this means that eval can only do calculations and call functions. It cannot assign new values. For that, we would need exec. If I run this now, we don't get an error and we get none because this here returns none. But after this, if I print the value of test string, we get updated, meaning this hello here has been updated. Now, looking at all of this, you might be wondering, this is kind of cool, but I am never going to use it. So what's the point? And there's also something you really want to be careful about, and that is that you never want to use eval or exec if there's any kind of user input. Let's say you have some kind of name input and you're running this in the exec function. The user could write any kind of Python code and have it executed. That's the sort of thing, if you run a database, is just about the worst case scenario and would probably get you fired if you're doing it for a job. So do be careful. Now, for one example that we could run in here is, let me comment this out. And let's say you have some kind of object, in my case, test string, and you want to run lots of different methods on it. Let's say I have a test object here, in my case, test string, and I want to run a couple of different methods. I have upper, lower, case fold, and title. And once more, we have 4 different lines of code for something that should be fairly simple. And this can definitely be simplified. And how you do that is with a for loop. So for operation, in, and now I have a list with the string upper, the string lower, the string case fold, and then the string title. And now in here, I can just print my eval, and inside of that, I can get my test string, which has to be a string itself. So the variable name is a string. And then I want to call with dot the operation, and this then has to be an f string. And don't forget to actually call the function. And now I can comment out all of this, run this, and we get the same outcome. And this, I think, is significantly more readable than something like this. Although I guess you could debate about it. And again, this really isn't something you would use too often, and you do want to be careful when you use it, but when you do actually need it, it can be incredibly useful. This is then another topic covered. And with that, we can come to the next one, and this again is going to be really simple. All we're going to do is dict.get. Now, what does that mean? Let me copy in a dictionary that looks like this. Super simple dictionary with key value pairs. And if we want to print one of these values, I would get my test dictionary, and then I would use indexing with the name of the key that I want to look for. Let's say A. If I run this, I get the value associated with that key, 1 right here. The problem that you may sometimes have is you don't always know how many key value pairs you have in your dictionary. And this could crash your code. Let's say I want to check for key D. If I run this, I get an error because the key D does not exist. And we want to get some kind of way to check if this key actually exists. And for that, we could use dict.get. And this works kind of like indexing, meaning if I run this now with A, we get 1. If I run B, we get 2, and so on. The difference to normal indexing is, if I put D in here, the code doesn't crash, instead we get none. Which makes this kind of superior to indexing, because you don't crash your code if you don't get a result from the dictionary. And you are probably going to use this inside of an if statement. And that would look something like print, for example, like this. This only runs if you actually have a dictionary, and it returns a useful value. I guess you could do whatever you want inside of the if statement. The really important part is this line here to check if a key exists inside of a dictionary. All right, we are very nearly done. At the end, for the last part, we have list flattening. And there are a couple of ways of doing this in Python. In my case, I want to do this with sum. Let's say I have a list like this. And this is a list that contains other lists, meaning we have a nested list with 3 items, and each item contains other elements. And what I want to get instead is purely the list with all of the values, meaning the list should look something like this at the end. And again, there are a few ways of doing this. And the one you most of the time probably learned was list comprehension. But there's a very easy way of doing it. All you really have to do is print the sum of this test list and then add an empty list. And if you run this now, you get the actual list flattened out. Unfortunately, this only works if there's one level of nesting, meaning if we add a few more values inside of a list at the end, this is terrible typing, so 10 and 11, this wouldn't work as well anymore. But if you have a very simple list with a couple of lists inside, this can be incredibly useful. And I guess really quickly, the reason why this happens is when we are running sum of a test list, Python is going through every single list. It starts with this one, and then this one. Meaning we are starting the sum of this list with this empty list here. And in Python, if you add one list to another, you are just merging all of their values. So what we're doing in here basically is we have an empty list, and to that empty list, we're adding 1, 2, and 3. And this we are then doing with the other list as well. And at the end, this list is basically being filled with all of these values. It's kind of a hack, but can be really, really useful in some very specific circumstances. And all right, with that, we have covered all of the tips. So I hope that was helpful, and I see you around.